Aloha, Richard Halverson here. This is ITS148, and today I'm going to go over the section on heaps and do the challenge activities. So let me share my screen. All right, so this is heaps. Heaps is my favorite binary tree data structure because I think we do a lot with them and they're easy to manipulate. So a heap is just a binary tree that where each node, the heap property is that each node is greater than or equal to its children. And so the way you figure out if a binary tree is a heap, each node has a value. The way you figure out if it's a heap is if you look at each node and it's got to be a heap. So here, for example, this 98 is bigger than 50 and it's bigger than 22, so it's a heap. Here, 98 is bigger than 50 and 22, heap so far. 50 is bigger than 49 and 47. It's a heap so far. 22 is bigger than 14. So then, yes, this is a heap also. So this is a max heap. A min heap is where the smallest one, where the parent is smaller than or equal to its children. So that's a min heap. But this is a max heap. Now this one is supposed to answer this question. 33 violates the max heap property due to it being greater than 22. No, that's false, obviously. 54 violates heap property due to be greater than 54. No, that's not anything. 60, no, that's not. Oh, wait a second. Yes, 60. No, it's not 60. It's the 60 violates the max heap property due to it being greater than 60. I think that 56 is not a heap because 60 is greater, but I don't think that makes 60. So let's see what it is. False. 55's parent is 60, but 55 is not greater than 60, so is a violation of the max heap property. I think we must be looking at the tree as a whole. So anyway, max heap properties root must have the maximum key. Yes, that's true. So anyway, the answer to this one is this. Anyway, okay. Terms. Okay, so so for max heap, there's insert operations and there's remove operations. The only time you ever remove is usually you remove from the top. And when you insert at the bottom. And so whenever you insert or whenever you remove, you have to reheapify it. See, so inserting means, like, for example, here we're sticking an 85 on the bottom, and then the 85 has got to percolate up to its proper spot. You see, 85 is bigger than 80, so we exchange 80 and 85, and then 85 is smaller than 88, so it's done. That's what's being shown here. When we remove a node, we would remove the 88, and then we would take the 80, that's the last one, we put it up here, and then we would have 80, and then 85, and so then the 80 would switch places with the 85, and then so the 85 would be up here, and the 88 that way. In the end, it's going to look like this. It turns out that given n nodes, the height of a max heap is always log to the base 2 of n. This is a min heap. A min heap is similar to max heap, except for it's the node's key is less than or equal to its children's keys. So here we can use it to waiting for online tech support. This is an application of heaps. So I'll go through this. Okay, so here's a challenge. Select all the valid max heaps. So this is pretty easy. Let's just start this out. Let's see. Is this a max heap? 65 is bigger than 40. Yes, this is a max heap. 97 is bigger than a 92. 94 is bigger than this. 90, that looks like a max heap to me. 29, wait. Now I don't, all right, well, this is not a, heaps, heaps look like more like this than like this. We'll get to that later. Anyway, this is not a max heap because 64 is bigger than 29, so it violates the heap property. This one, 66 is greater than 57, 16 is greater. Yeah, this is a max heap. So I think this is right. All right, good. What's next? Which operation makes the tree a valid min heap? Which operation? So we have to percolate down something. So this is smaller than this and this. This is smaller than this and this. This is not smaller than this. So I think I think 66 has to percolate down. I think that's what we're supposed to do. I think that's what this is asking. Percolate down 66. This is right. Ah, yes, okay. All right, what's the next one? Given the max heap, 97 is added. Well, you add it down, you would add it right here, and then you would reheap. And the new node with key 97 is added as this is going to be the left or the right child of 77. Okay, so 97 is going to be here, and then 97 is going to switch places with 58. Here, let me do this. Might be easier. There's time. Do I have a pen here? Let me put this like this, and I got this thing over here. Let's see how well this works. I'm going to use this color, and I'm going to say we've got 95. Here, let me do that. 95, 93, 58, 18, 14, 46. Okay. First thing we do is we're going to add 97. So 97 is going to go here. Okay. And then we're going to have, and then we have to reheapify, and 97 is going to switch places with 58. So this is going to be 97. Oops, what am I doing? This is going to be 97, and this is going to be 58. So that's the first thing. And then we see that 97 is bigger than 95. So that's going to, so these are going to flip. So 97 will be here, and 95 will be here. And that's still bigger than 46. So what we end up with is 97, 95 for this is like 58. I hope this makes sense to you. Anyway, 97 is going to be at the top. We can erase this and erase this and erase this and erase this. And it looks like it ends up looking like that. Okay, so what's the question? The new node with key 7 is added as the okay. It's added as it's added as the child of 58. See, so I'm going to put 58 here because that's where it's added initially. That's where I put it initially, right down here. And then I percolated 97 up, swapping with keys. It swaps with 58. Oops. 58. I hope this is right. And then it swaps with 95. 95. Oh, so let me give you, what is it? Oh, 58 comma 95. Just letting me do that. 50 8, 95. All right. All right. Does that work? Oh. Oh, I was supposed to. Okay. Let's try again. Is it the same one? 58, 46, 58, 95, 97 is added as the right child of 58. Yeah, right. Right child. Left, right. Okay, good. What's the last one? Okay, given the max heap, remove the max heap. Okay. So a, a remove from the max heap returns. Okay. So we're going to remove from the max heap. That means we remove 80 because we remove the top one. And 80 returns 80 and yields which one of these? Well, 80 is gone, so that eliminates A right away. See, when 80 is gone, then um, 80 is gone. So then we take 20 and we put it up here. Let's do this. Try this one instead. Oh, let me just erase this. Okay, so we start out with 80 and 59 and 56 and 17 and 40 and 31 and 20. Okay, this is what we start with. And we remove the 80, and removing the 80 is going to remove the 80, and it puts the 20 up where the 80 is. So when we're done removing the 80, we end up with this is gone. Getting rid of this. And 20 goes here. I'm going to use this color. 20 goes here. And now we have this. Okay. And then we're going to have to heapify this. So 20 trades places with 59. So this goes 20. And this goes 59. And then 20 is going to trade places with the bigger one, which is 40. So this becomes 40. And this becomes 20. So in the end, we have 59 on top. That's 40 on the left, 56, 17. We end up with, see, I'm gonna, can I? Okay, we end up with, let me just erase, this is gonna be 59, 59. This one is gonna be 40. And this is going to be 20 down here. So 59, 40, 56, 17, 20, 30. I think it's B. 59, 40, 56. No, that's not. Where's 30, 31? No, 31. Oh, no. See, it's going to be B. B. All right. Is that right? All right. Very good. All right. So that's that one. Let's go to the next one. Heaps using arrays. Okay, so heaps are nice because it's really nice to represent a heap as an array, as a an array without any, I can't remember what it's called, but it's where all the elements are efficiently to the left. So it's built like this, where this is the first element, and these are the next two elements underneath that, and then the next four elements would after that, and this is the child of this, this is the child of this is the child of this, and so is this. Then this has children here, and whatever the next one would be. So that's it's real easy to represent it, and it's real easy to address the child of an element by their indexes. The children of an element by its indexes. It's easy to just by using an equation. Calculate what the parent of a child by its index, and the children of a parent by its index. All right, so this is match each max heap with a corresponding storage array. Okay, so this is going to be 57, 42, 19, 13, 6, 7, 15. 57, 42, 19, 13, 6, 7, 15. So this one is A. This one here is A. And so it's real easy. This is 57, 19, 42, 13, 6, 7, 15. This one is 57, 42, 15, 6, 19, 7, 13. 57, 19, 42, 6, 7, 13, 15. See, that's very easy. All right. See, so, and this is how you calculate. This is example, but this is how you calculate. So you have a node, and the parent of that node is you subtract 1 from it, divided by 2, and you take there's a fraction, you back off the fraction. The children are the index. You take the index, you multiply it by 2, add 1, that's the left child. Or you take the index, multiply it by 2, and add 2 to it, and that's the right child. Very easy. All right, let's figure that out. This is the percolate algorithm. This is percolate up. And this is the max heap percolate up. That's when you add a new node, you put it at the very end, and then it percolates up. And when you remove a node, you take off the top, and then you take the bottom, the very bottom one, and put that at the top, and then you percolate that down. So that's percolate up and percolate down. And by percolating, you just compare it with like percolating down, you compare it with the two children, and you exchange with the bigger one. And percolating up, you look at the parent. If you're bigger than the parent, then you switch places with the parent. All right, heaps using arrays. Okay, so here we have 95, 89, 45, 41, 79, 26, 3. Okay, start. What is the above max heaps array form? Use value. Okay, so I'm going to say 95, comma 89, comma 45, comma 41, comma 79, comma 26, comma 23. 23, 26, 79, 41, 45, 89. Okay, so that's the first one. What's the next one? What are the parent and child indexes for a node at index number 7 in a binary heap? Okay, so if the node's at 7, and you want to know what the parent, what's the parent of 7 is 7. The parent of 7 is 7 minus 1 is 6. Divided by 2 is 3. 3. What's the left child? 7 times 2 is 14, plus 1 is 15. 15. And then this one would be 60. 60. Yeah, is that right? Yeah, pretty easy. What's the third one here? Select each array that represents a valid max heap. Okay, so 35 has got to be bigger than 35's children is 59 and 60. 35's children is 59 and 60. Well, that's not a max heap already. 32's children is 46. No, that's not a max heap. 62's children are 18 and 32. That's a valid heap. 18's children are 18 and 16. That's a valid heap. 32's children are 12 and 11. Well, that's a valid heap. So I'm going to say that's a valid heap. What about this one? 29 children is 30 and 36. No, that's not a valid heap. Okay, so that's what I'm going to do. All right, what's next? What is the resulting array of 43 is added to the max heap? Oh boy, I'm going to pull out my diagram thing right here. Let me erase this. All right. So first of all, I'm going to make, here it is, 36. First of all, I'm going to make the heap. It's going to be 98, followed by 75 and 58. And then below 75 is 48 and 62 and 56 and 44. Insert those around here. And we are, what is the result? Well, the resulting array of 43 is added to the heap. Okay, so 43, this is full, so 40, we're going to start a new level. This is going to be 43. That's added there. And then we're going to percolate up. Well, I'm going to change this color. 43 and 48 are going to change places, so this is going to be 43. No, it's not. It's already a heap. It's already a heap. What am I doing? Can I undo that? Yeah, I think this is already a heap. 48 is bigger than 43. 75 is bigger than 48. So it's bigger, bigger, bigger. I think that's it. So what is the resulting array of 43 is added to the max heap? Well, it's just going to be, it's going to be the same thing with 43 added at the end. So it's going to be 98, comma, 75, comma, 58, comma, 48, comma, 62, comma, 56, 44, 43. It's just going to look like that with 43 on the end. All right. Very good. What's the last one? What is the resulting array of 69 is removed from the max heap? It's a max heap. It's a max heap, so it means it's going to be valid. So let me erase this thing here. So we've got 69, and we've got 61, and we've got 69, and we've got 55, and we've got 16, and we've got 49, and we've got 35. So this is absurd. This is a heap because its children are less than or equal to, valid, less than or equal to, less than or equal to. Okay, so what are we going to do? We're going to remove the 69. So this, what happens is the 69 goes away down here. And the last one, which is 35, that gets put up here. So this now becomes 35, and this is gone. Okay, so what it is going to be, I might as well put, erase this on this. Yeah, this is going to be gone. This whole thing is gone. Actually, it's replaced with a 69. And this is a 30, 35. I think that's what that was there. 35. So now it looks like this. And now we have to percolate the 35 down. So what's the biggest one? What's 35's biggest child? It's 69. So these two trade places, and this becomes 35, and this becomes 69. And now 35 is here, and 35 is smaller than 49. So they're going to trade places, and 49 is going to come up here, and 35 is going to come down here. So what we end up with is 69, 61, 49, 55, 16, 35. Okay, does that make sense? So I'm going to just put that over here. 69, comma, 61, comma, 49, comma, 55, comma, 16, comma, 35. So that's how it should end up. All right, very good. Okay, the next section is talks about how to implement heaps in Python. And, you know, even gives you the Python code down here. So make sure you understand this. It's the heap program, heap sort. No. Is this the whole heap sort program? Okay, so we have oh yeah, the class comes with the class. Here's percolate up, percolate down, and inserting, which should be inserting at the bottom, appending at the bottom. Removing, where you're removing from the top. So you take off the top one. And there's this. Okay, so anyway, make sure you understand that. You don't have to write any code in it. And here's heap sort. And the way you do heap sort is you just you pop off the top one, and when you pop off the top one, of course, you take the smallest one, put that up there, and you percolate down. Okay, first thing you do is you heapify it, and heapifying it. Okay, so the bottom nodes, to heapify, you start at the very bottom, and then you heap each one up as you go up. Well, the bottom row is already a heap because it doesn't have any children. So the first one you have to worry about would be 92. And so you check to see if 92 is a heap. If it's not, you make it a heap. And then after 92 is a heap, then you go over here and you check if 55 is a heap. Well, this is not a heap, so this 55 would percolate down. And then after that, you do this one, and then you, so if you can click through this and see that's what happens step by step. Max heap, largest internal node index, internal nodes. See, these are, when you're heapifying it, it's all internal nodes that you heapify. The bottom ones are already heaps because they don't have children. Anyway, so go through that. Is this here's a last. I think this is the last, is it? 18.4? Yeah, it's the last one, last challenge. So let's do this last challenge here. All right. Given the array, heapify into a max heap. Well, gee willikers. Let's do this. I haven't done this one yet. Okay, we have a heap. No, we start out with a thing that's got an 82, and then it's got a 92, and then it's got a 75, and then it's got a 33, and a 60, and a 59, and a 89. Oops, 89. And so to heapify this, The bottom row is already a heap, so we start with 75. Is 75 a heap? No, 89 is bigger than 75, so we got to trade places. This becomes 89, and this becomes 75. And then we go here, 92. Is 92 a heap? It is. Then we go here. Is 82 a heap? No, it's not, because 92 is bigger and 89 is bigger too. So we get to take the biggest one, put the 82 down here, and we put the 92 up here. Okay. Now, is it a heap? Is 92 a heap? Let's see. 92 is bigger than 82 and 89. That's good. 82 is bigger than 33 and 60. That's good. 89 is bigger than 59 and 75. So what we end up with is 92, 82, 89, 33, 60, 59, and 75. So let's plug that in here. Start. 92, 82. That's what I'm doing this right. 82. I'm supposed to heapify it, right? Okay, 82, 89, 33, 60, 59, and 75. All right, is this right? Yes. Okay, what's the next one? Heap sort has heapified an array to this and is about to start the second loop. Okay, after it's heapified. Okay, they're talking about this is the first loop, which heapifies, and this is the second loop, which pops them buggers off and percolates, reheaps it. Okay, so the heap sort has already heapified the array and is about to start the second loop. Well, I'll tell you what, I'm going to make sure I can envision this. And so let's look at this heap. It's got 96, and it's got 65, and it's got 59, and then it's got 37, and it's got 39, and it's got 18, it's got 23. Is that a heap? My goodness, it is, in fact, a heap. 59 is a heap, 65 is a heap, 96 is a heap. Okay, and then we're supposed to start the second loop. What is the array after the iteration, the first iteration for the second loop? Well, 96 has been pulled off and it's down the bottom. It's actually replaced. This is actually what happens. 96 goes down here, and 23 goes up here. Let me do that different color. 23 and 96 trade places. So 23 goes here, and 96 goes here. But 96 isn't considered part of the array anymore. 96 is off, and so it's really just 18, 39. This is the array. This one, this one, this one, this one, this one, this one, and it stops here. Stops there. I couldn't see that. Anyway, so it looks like this, and then we have to reheap. We have to reheapify this. This is not part of the heap anymore. This is not part of the heap anymore. We have to reheapify this, and so 33 trades places with its largest child, which is 65. So this becomes 65, and this becomes 23. And then 23 trades places with its largest child, which is 39. So this becomes 39, and this becomes 23. So when it's all over, we've got 65 at the top, and then we've got 39 next, and then we've got 59 next, and then we've got 37 and 23 and 18, and then 96 is going to be at the end. It's actually going to be at the end because it's built from the end. So I'm going to put that down and hope I get it. 65, 39, 59, 37, 23, 18. 96. 65, 39. No. Okay, 65, 39, 59, 37, 23, 18, and then that's the end of the array, and this is stuck on the end. See if I get it. Oh, yes, very good. All right, what's the last one? Heap sort as heapify the array into that. Okay, and is about to start the second loop. What is the array after each loop iteration? Well, this is going to be really fun. So I'm going to start with we started with 90, 81, 72, 35, 11. So that's what we start out with, and is about to start the second loop. After what is the array after each iteration of the loop? Well, the first iteration is going to be the 90 is going to be put down here, so I'm going to build that down here. And it's going to trade places with the smallest one. So 11 comes up here, and this is gone. This is 90. And then now you have 11 up here, and we have to percolate the 11 down. So we take the largest child, and that's the 81. So the 11 goes over here, and the 81 goes over here. And then we have 11 here, and we got to replace that with its largest child. There's only one child, and that's this one, because this one is not part of the array anymore. So it says is 35 larger than 11? Yes, it is. So we're going to put 35 here, and we're going to put 11 here. So what we end up after this iteration is first there's 81, 81, and then 35, and then 72, and then 11. So I'm going to put that there. So it is 81, 35, 72, and 11. And then 90 is at the end, of course. Okay, so that looks like the first one. Oh, I can't check that. All right, so let's and now let's rewrite this. Can I like can I do this one? So I'll do this, and I go like this. Okay, I'm gonna go like this, and I'm gonna go back like this, and I'm gonna write it again. I'm gonna write what I have now, and it is 81, 35, 72, 11. And then the 90 is really not part of this. Okay, I'm gonna leave the 90 down here because that's not really part of this. Okay, now we're gonna pop off. We're gonna start the second loop, and we're gonna pop off the 81. We're gonna put the 81 down here. We trade places with the bottom one, so the 11 goes up here. The 11 goes up here, and the 81 goes down here. Really, the 81 is here, and this isn't really here anymore. And so now this is really what's left. And so 11 is we have to percolate the 11 down, so it's going to trade places with its biggest child, and that's 72. So this goes to 11, and this goes to 72. And what we end up with at the end is 72, 35, 11, and then these. So we end up with 72 and 35 and 11 And then we put the tail of the, you would put these last ones in here, which is 81 and 90. All right, so that's the second one. That's second iteration. And so what about, so that's, and we have 80, yeah, and then let's do the third iteration. I'm just gonna slide this up a little bit like that and go back to, what is this? Go back to writing. Oh, okay, sure. And so I'm gonna write it again, and it's gonna be 72, 35, 11. And that's really it, because the other ones, which is 81 and 90, they are not really part of this because they're really down here, 90, 81. And so these aren't really part of it. It's just this is the tree. And so what do? We pop off the top and we exchange it with the bottom one. So this becomes 11 and this becomes 72. And the 72 actually gets hacked off and 72 gets added to the already sorted part of the array. And we end up with 11 now. 11 and its child is 35. We have to percolate it down. So the 35 and the 11 trade places. This becomes 35 and this becomes 11. And so now all we have left is 35 is the first element and 11 is the second element. 35, 11, and then 72, 81, and 90. So let's do that. 35 is the parent. Yes, okay, so it's 30, 35, 11, 72, 81, and 90. Okay, so that looks like after the fat iteration. And so what we end up with, so now I'm going to draw it again. So I'm going to write this again. I've got 35, 11, and really that's it, because the 72, 81, and 90 are already the top end of the sorted part of the array. So really this is the only heap we're looking at now. And so we pop off to the 35, the top one. We trade places with the 11, so we end up with this is 11, and 35 is gone. It's now part of the list here. 35 is now part of this list. And so now we have this sorted list of 35, 72, 81, and 90, and the 11 is at the top here. That's all there is left. So after the last iteration, it is 11, 35, 72, 81, and 90. Okay, I think this is right. This is the sorted part. Then, and this is the sorted part, and this is the remaining heap. And then this is the sorted part, and this is the remaining heap. And then this is the sorted part, and this is the remaining heap. And then this is the sorted part, and this is the remaining heap, which is just one item. So anyway, let's see if this is right. All right, very good. Okay, well, that concludes the challenge activities in chapter 18. So the next video I will make is this last lab. So hope this helps. Thanks for watching.